This is chapter 10, the nature of energy. Some key terms in this chapter is energy, the ability to do work and produce heat, potential energy, which is stored, and kinetic energy, which is energy that's in motion. And another term is law of conservation of energy, which is energy that can be converted from one form to another, but it can't be created or destroyed.
Temperature and heat. Temperature is a measure of the random motions and components of a substance. Heat is the flow of energy due to temperature difference. Exothermic and endothermic processes. Endothermic is when heat flows into the system from surroundings, and exothermic is when heat flows out of the system to the surroundings. Here's an illustration of what that looks like. This is endothermic, and that's exothermic. See this? This is the container, and the heat's going out into the surroundings. And this is a container, and the heat's going in the container from the surroundings.
Thermodynamics. It's the study of energy. The first law of thermodynamics is that energy in the universe is constant. An equation is change of internal energy equals heat plus internal energy. When heat's positive, endothermic energy goes up. But if Q is
Go.
Thermodynamics. Thermodynamics is the study of energy. The first law of thermodynamics is that energy in the universe is always constant. An equation in thermodynamics is the change of internal energy equals heat at work plus internal energy. That's delta E equals Q plus E. If heat is positive, then the endothermic energy is positive. But if the heat is negative, then exothermic energy is negative.
Measuring energy changes. Units of energy and heat include calories or joules. 1 calorie equals 4.18 joules. Don't get mixed up with food calories. Scientific calories are different. 1 food calorie equals 1,000 science calories.
Alright, so let's do a sample problem. We have to express 60.1 calories in joules. So what we're going to do is multiply 60.1 by 4.18. So then we get 24.8 joules, which equals 6.8 calories. Wait, that's not right.
Yeah, it is.
Oh, it's 251.
Oh, scratch that out. Scratch that out.
Wait, where did the 24.8 come from? Okay, now
You scratch that out too.
that equals 251 joules.
Yeah. Calorimetry is the science of measuring heat. A calorimeter is a device used to determine the heat associated with chemical reactions. An example of that is a styrofoam cup. The equation we're given is Q equals ms delta T. Q being energy or heat, which is calories or joules. S being specific heat capacity, which is calories per grams times C, or joules per grams times C. M being mass, which is always grams. And delta T being change in temperature, which is degrees Celsius in this case. Okay, for an example problem, we're trying to find energy in joules to raise 7.4 grams of water from 29 degrees Celsius to 46 degrees Celsius. So what we're trying to find is Q. Okay, we're given mass, Mass is 7.4 grams. We can find the delta T by taking 46 degrees Celsius and subtracting it by 29 degrees Celsius, which gives us 17 degrees Celsius. So now that we have oh yeah, and S is 4.18 joules per grams times the C or something. I don't know. So now that we have three variables, we can plug them into this equation. Q will equal 526 joules.
Alright, so our sample problem here is when 1 mole of CH4 is burned, 890 kilojoules of energy is released. And we gotta calculate the change in temperature, or the change in heat when 5.8 grams of CH4 is burned. So we start off with the given, which is 5.8 grams of CH4, and we convert it to moles. So that'll be 0.369 moles. And then we do cross multiplication with the other given, which is 890 kilojoules of energy. So we set up our proportion, which is 1 mole for 890 kilojoules, and then 1 mole for the given 0.369, and we solve. So we cross multiply, and we get negative 328 kilojoules.
Okay, this is the heating curve of water. These numbers represent the equations that are coming up in our lecture. So you start down here, it's ice, and then you go up in the heat, and you get to ice water, then you go up here, and it's like you're getting up to liquid water, then right here it's water and steam, and then you get to 5 and it's steam. It's all steam. And then on the next page, these numbers go match with the graph on the previous page. These numbers. So one is Q equals SM delta T. Number 2 is Q equals moles times 6.01 kilojoules per mole. Number 3 is Q equals SM delta T, but with a different value for S. Number 4 is Q equals moles times 40.6 kilojoules per mole. And number 5 is Q equals SM delta T with another different value for S. So let's work through an example problem. We want to calculate the amount of energy in kilojoules required to bring 100 kilojoules of ice at negative 32 degrees Celsius to steam at 115 degrees Celsius. So that means we would have to go from ice to steam, which means we'd have to use all 5 equations. So this is basically all the work. And when you get all the values for all the equations, you add them up. And that's what we got. 310,528 kilojoules.